Exam 3 review. We are asked to find the standardized t statistic, and okay, set up here. Asking to test the claim about two means that are equal to each other, so two samples, random and independent, which is needed to be able to do this. And they come from populations that are normally distributed. So this whole sentence here is just letting us know it fits the needed requirements to be able to use a t-test. The sample statistics are given below, and then we're asked to assume these symbols are that the population variances, right? The sigma 1 squared. So the the population 1's standard deviation squared, that's a variance, is equal to the other population's variance. So this is just telling us that the variances, supposed to be a C, the variances are equal. An I or an E, variances. The variance. Okay, sorry about that. And then we're giving sample statistics down here that we can input. But since the variances are equal, what does that tell us? It tells us that we're going to do a pooled t-test. Because since the variances are equal, the formulas basically can combine in a way without getting into too technical of an explanation. We're going to do a pooled t-test. So that's what you'll look for. Are the variances equal or are they not? You'll see in question 10, the variances are not equal, so we cannot use the pooled t-test. We use a regular t-test. Okay, so let's go ahead and see what this looks like with a pooled t-test. So we start by going in the menu down to inferences. We're going to run a test, and we're doing two proportions because we have two samples. Wait, no, sorry, not proportions. We have means, so we are doing two means. And that's, yeah, you see here, two proportions is always going to be a z-test. So we're asked for a t-test. We can only do that with means. When we get here, we have two types of t-test, a sort of regular t-test and the pooled t-test. Since the variances are equal, that's the symbol right here, and it just it does it either way. I think in the homework it just says variances are equal. So we're going to do a pool t-test. The answers we come up with are slightly different, and I'll show you that in once we go through this the first time the right way. Okay, so we're going to do pool t-test. The claim is that the the means of the two samples are equal for the populations, and so if you subtract them, you'll get 0. So with that as the claim, the complement of that is that the two are not equal. We don't know if they're greater than or less than, but we know they're not equal. So we go with this one. It's going to be a two-tailed test. We go to next. We're going to input our statistics. So and be careful here. It's real easy because of the way they list this, maybe to put the wrong things in the wrong place. So sample 1 mean is x bar 1. That's going to be 11. Sample standard deviation 1 is the S1. That's 2.5. And then the sample size for sample 1 from population 1 is 14. The mean from sample 2 is 12. So you got to go through these real carefully. Standard deviation is 2.8. And then the sample size we're given is 12 for N2. Level of significance, they don't give that to us. The thing is, they're not asking us to make a determination to reject or fail to reject. So we can actually use any significance level we want because all we're getting is the t statistic. That will not change. The thing that the significance level changes is whether we reject at that amount or not. So I'm going to leave it at 0.5, and I'm going to come back and show you that I'll change it to a 0.10, and it still won't change the calculation of the t statistic. Okay, so we go to the next. Here's our t statistic, negative 0.962. And so I've got my answer for up here. It's going to be B. Okay. Did they get some of the other wrong answers? It's not quite, not quite sure. Let's come back here under these statistics. I'm going to show you that I'm going to change significance level. Let's go to a 15%. We wouldn't use that much, but I'll just show you that it does not change the calculation of the test statistic. It would change on whether we reject or not reject, but we don't. Actually, this p-value is not very good. We're not going to reject it anyway for a lot of things. But anyway, it doesn't change the t-value. So don't let that throw you. Sometimes you're not given a piece of information, and for what they're asking, it's telling you you don't need that. Okay. One more thing. Let me back up here. I'm going to see if I can do this relatively quickly with a regular t-test. See if it copies it over. If it doesn't, look, it shouldn't take me too long to put everything in there. Yeah, statistics aren't the same, that didn't get copied over. But I just want to show you, if you put it in the wrong test, you're going to see we would not arrive at the correct value. So this should give us a value that does not appear here. See, 2.8. And of course, we're done with the problem. So if you wanted to get out at this place, but I think this is kind of important. And we saw the significance level doesn't matter. We got 0.954. It's not on here. Now, in this case, you probably would have said, okay, I'll just go to the closest one and, choose the best answer, because in multiple choice, that's what you need to do. However, in a test question, this might be an answer that's showing up, and you might think, oh, I got it right. But see, there's we want to make sure that you're doing the right test. So if you don't do the right test, you actually don't get the